Okay. Finish up here with the immune system. I think we're on slide 42, I think is what this one is. We talked a little bit about T cells. There are different types of T cells. We've got suppressors. We've got cytotoxic. We've got helper. They each have a little bit different role. And I think I mentioned this slide to start with last time, so we'll start here. As far as immune surveillance, this is just patrol going on around, not necessarily in response to something specific, but what's constantly monitoring. We've got some T cells that play a very vital role in terms of just surveying and keeping track of and finding, for example, cancerous types of cells, getting rid and dealing with those. So we've got the interplay of cytotoxic T cells. Remember, those are the ones that can destroy things. Natural killer cells, which are up here abbreviated NK cells. Those are more generic types of cells, or not as specific. Natural killer cells are sort of generic types of blood cells, white blood cells that target viruses. They target virus-infected cells. They are not nearly as specific as like T cells are. They are more general, but they're not like generic big macrophages that go around eating stuff and that kind of thing. They're just highly specific, specialized cells just to target and run into like virus-infected cells. Macrophages, we've discussed at length. We already know what those do. And interferon. We've already talked about the role of interferon to be released by a virally infected cell so that nearby cells can get a heads up and start producing antiviral proteins so that they can, any material that's injected into it from a virus, it can be met head-on with these proteins and try to deactivate. So we've, in terms of interferon, now I talked about that with viruses, but another thing is what you'll see is sometimes there's a big overlap in terms of how our body deals with virally infected cells and how our body deals with cancerous cells, which is another piece of evidence that supports a viral origin of cancer. But excuse me, our body's response is very similar to like it would be against a virus that's inside of our body. So interferon is again going to inhibit multiplication of cancer cells and increase the ability of immune cells, killing ability of immune cells, like it does with a virally infected cell to recruit. The one is kind of gone, takes it for the team. It'll give out, interferon will be released and give the heads up to the nearby cells. You get sort of the same thing with cancer. If your body can recognize this thing as abnormally growing, interferon can be produced by that and spread through, and that's one sort of generic way that we can deal with a cancerous type of situation. Natural killer cells are the first line of defense against cancer. Prior exposure not required. As I said, they're not nearly as specific. They tend to be more virally related, and what you're going to see in the body is whatever's virally related is going to also be very close in conjunction with how it responds to cancer as well. Okay, cytotoxic T cells, they can defend, in terms of how we deal with cancer, if it is in fact a virus-induced cancer, something like the big HPV thing out there now. It's been known for a long time, but of course the vaccinations against it is fairly new, at least in terms of FDA approval. What you'll find is these cytotoxic T cells that are used for the rest of the body. We've been talking about the T cells that can recognize antigens and mark them and then destroy them and those kind of things. You can get some action by those guys against cancer as well, but realize it's more specific. It's got to be sort of like we have before with the immune attack. So the only time you're really going to get that is if there's actually some kind of virus that's involved with that cancer, to where there are viral pieces that can serve as antigens that can be puked up to the surface and that kind of stuff. If we have that, then your cytotoxic T cells can play a big role in the combating of that cancer. Macrophages, they can clear away any dead cells, engulf and destroy cancer cells that have been marked and sort of are becoming destroyed, like if they've been perforated or whatever, then the macrophages can clean all that up. So what we're looking at here is sort of how what we've talked about so far works in to battle cancer. That's the point here. Now, if there's some sort of cancer that can be recognized as non-self, if the cells have mutated to the point where their surface antigens are so different than your other cells that your body can recognize them, then you can get a full immunity response to them. B cells can start making antibodies against them. Now, that's not going to happen all the time. Sometimes there's not enough of a difference, and you get cancerous growth without being able to recognize it as foreign. Some cancer cells can't avoid, what's going on. They have actually, and this is what makes it even worse, They actually have, some cells that are cancerous have counterproductive blocking antibodies. In other words, they can cause their cell to produce their own types of antibodies that block the work of the antibodies that your immune system's trying to do. So you can see where you get nowhere fast if that's the case. I say here that your regulatory mechanism for all of this, how your immune system works, is going to be through the endocrine and the nervous system by negative feedback. We know what negative feedback is now. Okay? Just let it out, man. Let it out. Hold that in. You know what? Bring it on. I got so much crap flowing through me now. It's just, I'm just waiting. But, anyways, for example, I'll mention something about cortisol here in a second because it's on the commercial, like Cortislam and all that kind of stuff. So, interleukin-1 is, interleukin between white blood cells, 1, just because it's been labeled that, can turn on stress response resulting in release of cortisol. Now realize the stress response. What does this mean? When we get into endocrinology and talk about hormones, we'll get into this more. But for right now, realize one of the things that can happen is whenever your white blood cells are working and some of these chemical mediators are released, some of those mediators turn on the stress response to your body. And that is sort of outside of immunity. It can work in conjunction with immunity, but it's going to involve like sugar stores in your body and blood pressure changes, all that kind of stuff that will work alongside with what we're dealing here. Cortisol is going to be a hormone that we're going to discuss later. But as far as how it fits in with right now, realize that some of these chemical mediators involved with the immune response can cause the release of cortisol. Now when you do that, it says cortisol mobilizes the body's store of metabolic fuel to keep pace with energy demand when you're sick. In other words, what cortisol will do when it's released into your bloodstream is take your stored energy sources, fats, proteins, whatever that's in your body, and mobilize them. Turn them into things that are more similar to glucose that's flowing through your bloodstream in order so that you can get more of that to your cells, okay, to help defend against this attack to give your body more energy. That's what cortisol will do. However, realize that cortisol also mobilizes amino acids to repair tissue damage and suppresses the immune system. Now, what will happen is, it doesn't make much sense. You're thinking, why would it suppress the immune system? But it's a matter of timing. This is the negative feedback I'm talking about. Generally, this is not going to be released, and this trickle-down effect is not going to happen until your immune response has been mounted and things are already happening. So the goal is by the time that cortisol actually kicks in, it's time to wrap this up anyways. Okay? So it's sort of in a repair sort of stage. And what will happen is as cortisol does this, now you're needing metabolic fuel, you're building up, you're trying to repair this stuff, you're trying to get back on track. This is this mobilization of the metabolic fuel, breaking down of products in the body that are stored sources of energy, fats, muscle, that kind of thing. And by breaking down your muscle and your protein, you're going to release some amino acids. Those can travel to help any tissue damage, if there was anything associated with this disease or this infection. All of that's going to and as this increases, that's going to negatively feedback. That's shutting everything down. So what you have is a decreased sort of immune response. All this is released. You've got all your immune system working. It triggers the release of this, and by the time this accumulates, this is sort of shutting down. Okay, so that's the sort of negative feedback tie-in that we're talking about here. It says lymphocytes and macrophages are responsive to blood-borne signals. This is just saying, there are signals in terms of other chemical mediators that are there that can, once they increase in a certain amount of number, that'll be a negative feedback to come back to these guys and shut down their activity and slow things down. It's just a basic negative feedback loop that we've already talked about in different situations. Now, what I mentioned here is, why does this work? You think about like Cortislam and cortisol and the easy way to lose weight and all this kind of thing. Realize what it does. Okay, cortisol is sort of like it's similar chemically to it's a steroid hormone. Okay, but what you have is a situation where you're taking your fat stores, you're taking your bodily stores, and by increasing your levels of cortisol in your body, obviously mobilizing them, right? Getting them out from their storage form, getting them into the cells to be used, sort of pulling apart, think of it like that, sort of pulling apart any fat deposits or protein deposits or whatever. It sounds great, but what you got to realize is the trade-off that you get there. Number one, you've got a breakdown of fats, and you've got a breakdown of proteins, which could lead to acidosis because of the products that come from the breakdown of fats and lipids, right? Ketone bodies start to form. We've already discussed this. What's ketones in the urine, like the sign of diabetes, like glucose. You've got that stuff isn't getting in the cell. You've got breakdown of the reason that ketones show up again. Remember, in a person with diabetes, is because their body isn't getting enough glucose in, so they start breaking down fats and proteins and that kind of stuff. That'll elevate the level of ketones in their bloodstream, okay? Which end up getting filtered out into the urine and can be detected in the urine. Now, that relates to this situation in the sense that your body is not breaking down all of that because it's not got enough energy like a diabetic would, but only because this hormone is there making you break it down. So you would break that same stuff down, you would have the same byproduct as a person like a diabetic would have. You would have these ketones, you would have an increased chance of creating an acidic type of environment in your body. Now, long term, obviously, that's a bad idea. Now, probably in terms of short term, the biggest effect that you're going to see with abuse of cortisol is suppression of the immune system. Realize it's a natural negative feedback cycle. So the more of this you have, you may be mobilizing fat stores, but at the same time, you're probably dropping your counts. You're probably in a situation where your immune system is already more susceptible now to infection and disease than it normally would be. Okay. Because it's got a 30-day money-back guarantee and it's not FDA approved. You can buy whatever you want. Yeah, as long as someone has that little disclaimer on there saying that they'll give you your money back if you're not fully satisfied, and as long as they say on there that it's not FDA approved, which all of them do, they can sell whatever they want. I mean, look at smoking. Look at all the labels on. Well, I'm just saying, right? If you're gonna condemn them for this, I mean, why would they not do that? So they put the Surgeon General's warning on there saying you'll pretty much die if you smoke this product, and buy it if you want. So I mean, it may not. It doesn't. No, that's just what they say. No. I'm just saying. I don't even know. I'm just saying, that's what you're going to hear. That's what you're going to hear all the time, right? You're going to say, well, whatever. It's all a big conspiracy. I'm not here to get on. Yeah, that's what it is. They're just trying to weed down the population. All right. I was thinking, like, terrorist attacks. The easiest ways to get to this country is when I'm having a discussion of this in one of my other classes, is obviously the water supply. You can get to the water treatment facility so easily in all these cities. And instead of focusing on these big cities, we're so susceptible in cities like this that are bigger but not real big. Like if you ever drive by the water treatment facility out here, it's just there. You could hop the fence and get there in 3 steps. But anyways, then I was thinking of, Well, come on. I mean, these people are smarter doing this. They already know this. But I was thinking too, like cigarettes. Think of how many people the cigarette industry affects. If you could ever contaminate one line of those cigarettes, just think of how many. Anyways, now I'm officially on the government watch list because this is. You got to start thinking. So. All right, and then like a couple of semesters ago, I actually bought a little product that had uranium in it too, so I'm probably already flagged for that for my chemistry lab. I guess, whatever. All right, it says here. Obviously, we know that if the immune system is not functioning properly, a lot of diseases can set in. We know this. There's so many we could talk about here. Obviously, I don't have time to discuss them all. We've got SCIDS, which is severe combined immunodeficiency. It's basically a genetic situation in small children where they're actually lacking the production of B cells and T cells, which makes it very difficult for them to ward off disease, obviously. HIV, we've discussed sort of already. We've mentioned it at least. The biggest thing that it incapacitates is helper T cells, but do you remember what other cell it actually infects? Do you remember? There's one other type of cell that HIV infects. Well, no, the helper T cells are the only lymphocyte, really, of any significance, anyways. It can also affect macrophages, which are the more general type. But your biggest hit comes right here with your helper T cells. Now, on another note, we've got, here's a genetic condition. I just picked these two because they're two different types of things. You've got a genetic condition. You've actually got a contractible, a viral condition. Then you've sort of just got things that happen in your body that go wrong, in which case, your body can recognize it as foreign whenever actually it isn't. You have autoimmune responses. Your immune system turns against itself, whether it's from mutations, whether it's something goes wrong with antibody production, something happens to where you get this antigen-antibody reaction where it shouldn't happen. He smiles, too, because he's used to hearing it. The bruiser, man. Where are you going? Okay, allergies. Basically, it's in a person that has a normal immune response, gets hypersensitive. Their antibodies react with antigens that shouldn't, in normal people, not normal people. I don't know, not an appropriate word, I suppose. And the majority of people that wouldn't cause a response in those people. Now, it can be an immediate type of situation. It could be like within 20 minutes you have an allergic response to something. It could be delayed. It could be several days, up into a week even sometimes, or even longer. It just depends. But the difference between those timings largely has to do with the type of cells that you are involving. Like, for example, B cells versus T cells. Whatever response, if your B cells are what's responding to that, you're going to get a much faster response. Usually it could be within 20 minutes or so, within a day, within 2 days. If you're involving some sort of T cells in this response, this depends on what it is, it's going to take longer. A good example of a T cell response is poison ivy. If you get poison ivy, I don't know if that's in the notes or not, but generally poison ivy is not like a 20-minute thing, right? And it's not even a day sometimes. Sometimes it's like a day or two or a couple days. It just depends on the person. But that's a T cell mediated type of attack. The toxin that gets in the body, those antigens are presented by those toxins make up antigens on antigen-presenting cells. They're floating around, and your T cells actually attack those and try to destroy that. So that's why it takes a little bit longer. What you're going to see with immediate hypersensitivity, the stuff that's really fast, these allergies, they're very similar to what you would get when you have a parasitic infection. And what I mean by that is your IgE antibodies are the ones that are going to be involved. Remember we said M, A, D, G, and E. And the E antibodies, IgE antibodies, are going to be the ones that are involved in this hypersensitivity reaction. They're the ones that are going to be most easily interacting with these antigens that are present, these allergens. So your IgE levels are going to increase. More of those, because once they're activated, remember, they start to produce more of themselves. Those B cells, those plasma cells make more of those same antibodies. So you're going to get a rise in your IgE antibodies. You're going to get more recruited basophils. This is why you get like the swelling and the tissue edema with allergies and stuff like that, because the more basophils, the more what they secrete. What do basophils secrete? Begins with the histone, ends with amine. Histamines, right? Histamine. When basophils get recruited to the area, you get more histamine release, so that's why you swell up and that kind of stuff. Eosinophils are also going to increase. Now remember, eosinophils are the least abundant white blood cell that you're going to find. They're pretty much only going to be elevated under two conditions. Number one, a parasitic infection in terms of like worms and that kind of thing, or an allergic response. So you're going to see an elevated ESO count here with an allergic response. I talk here, delayed hypersensitivity, the ones that take a little while longer, like a skin rash or what have you. T-cell mediated, takes longer. So, I do mention poison ivy. So it says allergens from poison ivy can produce this. Also cosmetics, cleaning agents, all that kind of stuff. So again, the speed has to do with whether it's involving B cells or T cells, that kind of thing. Okay. Triggers for hypersensitivity. We all know that there's several. It depends on what you're allergic to, but here's some common ones: pollen, bee stings, penicillin. Actually, your body you're not necessarily allergic to penicillin itself, but for those of you if anybody is allergic to penicillin, your body breaks it down, right? And whenever you break down penicillin, that which is not used or whatever, it's the breakdown products that form antigens in some people, where their antibodies start to react with the breakdown products of penicillin. Again, not with everybody, but with some people. I guess it just takes a while to build up against it. I don't know exactly all the details, but nobody in my family, nobody in my family is allergic to it, so I don't know. Do you? I was going to say that's what I thought was more common, but I suppose certain foods, obviously like peanut allergies and all that kind of stuff. Molds. I thought this was interesting. Like dust, for example, people get allergic. They think they're allergic to dust, but really, it's the research shows that it's not the dust particles themselves, but the things that's on the dust particles. Like in this case, mites. These are tiny little biological organisms that can form antibodies against that. Feathers, same thing. The mites that are stuck on feathers, and this is neat too. Animal dander or animal fur, like cats. People are allergic to cats. They found that actually, what most people are allergic to, almost all people. It's not the fur. It could be mites and that kind of thing that might be in them, but what it tends to be is actually the saliva. And the cat they lick their fur all the time, so some of those particles off of the saliva, in some people they can induce an allergic response. We can form antibodies against that. So anyway, I just thought that was neat. And I'll tell you what else was kind of gross. You think about dust mites. Go into I don't know, what's that place? Denver Mattress, is that what it is over there on Furniture Row? Well, I'm not going to say don't go in the bed. I don't know. That's maybe gross too. But I'm just saying, back by the counter somewhere, I forget which one it is, there's a sign that has like the average percent of mass of your pillow. If you had a pillow for like 3 years or something, the average percent by mass of what is now dust mites in your pillow. And like they feed off your dead skin cells, right? So. No.
You have to. Especially if you think you're cleaning your mattress. Yeah.
Who's they? Who's they?
Rainbow.
Oh, just the sweeper people, not like Denver.
They pull back the covers on your mattress just a little bit cleaner. They don't even go like this. They just on there and turn it on. Like
So now you sweep your
they have rainbow written in nasty. Disgusting. They do it on your floor, your furniture, your They put one of our couch bag in the thing there. I'm getting a new cat.
Well, did you look at the filter before they started, though? That makes,
Yeah,
okay.
they have all these little white.
Oh,
They
okay.
have like a solid white body filter, and then they lay them in. Yeah, got this entire white dot.
That's nice. But that's a really gross statistic, though. You should check that out next. That's like, it was almost like a third, like 30% or something of like a 3-year-old pillow was like made of just like dust mites and their remains. Oh, I have no idea. I have no idea. That's gross, though. Allergens. Like I said, you're going to bind to and elicit more production of IgE antibodies rather than your normal IgG that would normally be induced in all of this. So that's the key there. Your IgE antibodies, some of them are going to be attached to mast cells. Some of them are going to be attached to basophils, both of which secrete histamine. So mentioned a minute ago, slow anaphylactic shock. Chemical mediators include histamine, slow reactive substance of anaphylactic, and eosinophil chemotactic factor. Usually, when you get this type of reaction, when you get an allergic response, as the cells are migrating, as they are interacting with the antibodies and the antigens are interacting, and cells are being involved, they are releasing some chemicals. And in some people, depending on the severity of this and how their body views, it could be something that's very, not very detrimental to the health of that person, but their body seems that it thinks to think that it is. If they do that, they will have some mediators that are released that go widespread into the body, and cause widespread vasodilation, and thinking that it's it's a sort of an overkill, and they're going to try to get blood everywhere all at the one time. It's going to plummet the blood pressure. That's your anaphylactic shock that we're talking about here, and it just, like I said, it depends on that person's response. You think of it a lot like with the toxins that are secreted, like wasp stings and that kind of thing. I know my wife got stung a few years ago. She hasn't been stung since, so we don't know the severity of it. Her mother has to, keep an injection just in case. But she had a bad response a few years ago. Her neck was swollen shut. She got stung right somewhere down here, and her neck was swollen shut. I don't know if it would still do that or not. It could be like in her case, she just got stung like 2 or 3 times right successively. So I don't know. That reminds me that when we went to the emergency room the other night, this had nothing to do with what we're talking about, but you were talking about like scooting people through, like when you're waiting in triage or whatever. I was sitting in there, and this guy come in. He was an older fellow. He just walks up, he's holding his heart. He's like, "I'm in atrial fibrillation," and the lady's like, and so the receptionist called for the nurse, and she was in there with my wife, and she says, "Hang on just a minute," and right back. And obviously they put a rush on these people. And what was funny. Well, not that it's funny, but what was amusing in this was he comes back a few minutes later in the wheelchair, and he stops and he apologizes to us. He says, "Hey, I'm sorry for cutting in front of you guys." He goes, "My heart's just not working tonight." I was like, "Man, you go right ahead. She's just throwing up. You got a ticker to worry about, You don't apologize for going into AFib." Anyways, I just thought that was funny. Anyway, here's how this goes: a whole allergic response, and some people you get a hyper one. So, all right, let's see. You got a lot going on. Like I said, in some people with an allergic response, not only do you get a situation where things get activated when they shouldn't be, but a lot of times you get those things that are activated that shouldn't be get activated overboard, and they even produce more than they normally would. So you get an excessive release of histamine, other chemicals, which are going to be those mediators that can go out, and some people cause anaphylactic shock. It just depends on the severity of what's going on here. like I said, symptoms are going to vary. Usually your response is localized. If you have something on your skin, you get a rash, it's there. Like where poison ivy lands, is, most of the time it's going to stay. Now, you can't go up to somebody who's got a response to poison ivy. Realize that poison ivy is, and this is what I don't understand about people, it's a T-cell mediated attack. It's happening inside your body. The toxins show irritation and cell destruction where these T cells are going, and the death of those cells, that's that itching stuff that you feel. You can't go up to somebody, rub it on them, and give them poison ivy if it's 4, 5, 6 days later and you're still itching. It's got to be spread. It's a toxin that lands on your skin from that plant. It's got to be spread right then and there. It can get on your clothes and set for a while, and then you could spread it to somebody else. But once it's in you and you've been cleaned off and you've got poison ivy now here, it doesn't just stay there on your skin. You wash it off. But that which is in there has already elicited a response, and you're already getting that. And once that response keeps going, you're not going to spread that to somebody else. And that's a big myth. And I don't understand why people I guess they don't understand how the T cells are involved with this. But it's underneath the skin. It's part of the immune system now, and it's not like a sneezing kind of disease that you're going to pass on to somebody else. Because you scratch, well, like for example, yeah. Well, it does, assuming it's still on your skin. I mean, if you go, like for example, say I'm weed eating, right, and I got a bunch of poison ivy everywhere. Obviously, if I hit that, who knows where it's going, anywhere it lands. But say it stays on my jeans, I go into the garage, I take off the jeans or whatever I touch, and it transfers. It's like that whole little germ. It's almost like a germ kind of thing. Imagine where all it's going to go and where all it can trace, and it's very, very. It elicits a large response in very, very small doses in some people. So let's imagine a matter of where you touch and where you move it. If it's still on your skin, you wipe your face, you take your shirt off. Well, not maybe for you guys, but you're moving around. You well, you're mouthing.
It tells me that it's poison ivy, puts on the same stuff, same kind of cream and everything, and it finally goes away.
Oh well, that's a different story. I don't know. But, okay, there used to be, and I used to get one. There used to be like a shot you could get. I'm not sure something happened legally with it. I think with the rights of it in terms of who owned it, so they wouldn't give it. Well, maybe it's different now. But several years ago, I remember getting them and it worked as far as I know, because I get it really, really bad, which sucks because I love being outside. But for some reason they stopped giving. I don't know if they give it now again or not. But well, I mean, it's not real high on the priority list. No one really dies from it or anything, so they're not going to. I don't know what they're doing lately. I just grin and bear it anymore. I don't worry about it. But when you're a kid, it really sucks, Anyways, obviously, you can localize it. Hay fever is going to be upper respiratory. Asthma within your bronchioles. Hives are going to be on your skin. They're generally localized. Antihistamines, obviously the point of antihistamines is to work against the histamine, right, that's released to prevent swelling, uncomfortableness, and the irritability associated with that. But you're not treating realize with all this, right, you're not treating the cause of what's going on, you're treating the symptoms. And that's all we're doing here with this kind of stuff. Adrenergic drugs are drugs that, I say, mimic sympathetic nervous system. I didn't get to talk too much about how that controls blood vessels, but sympathetic nervous system, in terms of the body, increased heart rate, blood pressure, that kind of stuff. Depending on the person and what their symptoms are, you could cause the sympathetic nervous system to elicit some sort of response to help what's going on here. Cortisol is an anti-inflammatory. Remember, we go back to cortisol. It suppresses the immune system, right? The one thing I talked about a while ago in a few slides about cortisol, how it mobilizes the stores and that kind of stuff. It also suppresses the immune system. So that's why it's an anti-inflammatory. Okay, it keeps that inflammation from happening. Okay. Whoa, does it seem bouncing up and down, or is it just me? I'll tell you what, man, I'm having some problems. Anaphylactic shock, I already mentioned this. So it's widespread vasodilation. These chemical mediators that are released during allergy go crazy. They go far and wide. The biggest problem is vasodilation of major blood vessels and bronchiolar constriction. Okay. Generally, they work opposites one another. Whenever your your blood vessels dilate to increase, the bronchioles sort of do the opposite. So circulatory failure, bronchiolar constriction, all of this stuff can happen. Skin is obviously our outermost, very generic type of defense against everything. I'm not going to go into too much of this because you should have learned this in basic anatomy, but the layers of the skin, you got your epidermis, your dermis, your hypodermis. Fatty part down here, blood vessels and receptors in this region, mostly dead stuff up here in this region, at least the very top, where your keratinocytes are. All right, so you can read that. That's pretty much what I just said there. Of course, you know that if you have a third-degree burn, you're way down here. You've actually seared off all receptors and that kind of thing. So growing back, that's a whole different story. But right now, you're in shock, and your receptors aren't even there. So you've got a big, big deal to worry about, though, in terms of bacterial invasion, susceptibility. With these two layers gone, you're just laying there exposed. Right? So, okay. Let's see. Glands. We'll talk about more about glands later with the endocrine system. So we've got sweat glands, sebum glands. Sebum is going to sort of secrete an oil that's going to protect the layer of the skin, which is going to be even another layer, the very, very first layer to prevent microbial invasion. Generally, none of this is a problem until it becomes breached, in which case something can get inside. That's the problem here. Okay. One thing I wanted to say, though, for those who might experience a tanning bed type of situation, I wanted to mention something. Take a look here. I want to talk about a couple of cells that are specialized that work in your skin layers. People don't talk about these too much, I don't think, but obviously the first two we do, but not so much the second ones. As far as what's going to participate in immune defense, you actually have some cells that are specialized in your skin that stay in your skin area. Obviously, your melanocytes are your pigment-producing cells. Okay, all of us are genetically programmed to produce the same type of pigment. It's a matter of how much of this pigment do we produce and how many of the melanocytes, per concentration do we have, that kind of stuff. So genetically, though, we're pretty much all the same in that respect. Sort of like the eye color thing. Our body only has a code to produce one eye color. It's a matter of how that color is distributed, how weak it is in the center, how strong it is on the outside, that kind of thing. What is that one color? I know. We all genetically really only have one eye color. It's a matter of the other proteins that are involved that distribute that color through our eye that gives us our different, or the lack thereof. The lack of this color gives you the blue appearance. Okay. Brown. Okay. Brown is really the only eye pigment that's present. You get different shades of brown with other, the absence of it because of the other chemicals that are present. When light reflects off of it, you'll get a blue color. Green. If you look at someone who has green eyes, you'll see someone with hazel eyes like mine, if you look real close, you'll see actually concentric rings. Sure I do. You've got, well, it's the light. No, but if you have like a yellow, there'll be like a yellow ring, there'll be like a brown ring, there'll be a green ring, and like a blue ring, and then when you stand up far away, it sort of looks like that color. Mine actually change sometimes. It depends. Some of the rings get bigger on different days than others. It's kind of weird. Anyways, your melanocytes produce your pigment. Now, what's the point? Obviously, and if you think about the way the world works and where people are indigenously from, obviously the melanocytes produce pigment to protect from UV radiation. So those peoples that are indigenous to the equator type of area that are going to get more sunlight, obviously have adapted over time to have more melanocytes in their body to filter that UV radiation. Of course, the world is becoming a lot easier place to navigate. People are spreading all over the place, so we don't see this as much as what we once probably would have, but we still see it in a lot of cases. So obviously, it's to help sort of filter out some of those UV rays that are coming into our skin. Now, your keratinocytes produce, as they are dying, these cells, as they are dying, produce these keratin molecules, these proteins, that's sort of like a waxy material that can waterproof. Your hair is coated with keratin, your fingernails, that kind of stuff, high concentration of keratin, but also the surface of your skin. All right. Also, they secrete interleukin-1 for T-cell maturation. So, if as they are being activated, as they are dying, things like that help control T-cells are going to be involved with that. Okay, now, these two, Langerhans and Grunstein cells. The Langerhans cells, notice what they are. They are antigen-presenting cells. They are things that grab bad things and stick up to their surface so that other things can recognize it. Okay? Now, they are more susceptible of the ones that are listed here. Your Langerhans cells are more susceptible to UV damage. What does that mean? I say it's leaving behind predominant suppressor signals. So let me explain this, and then we'll put them together. Granstein cells inhibit skin-activated immune responses. This is your balance for all this, sort of like a suppressor T cells kind of thing. It kept everything in checks and balances. The Granstein cells are going to shut down what's going on with this. They inhibit skin-activated immune responses. Things that would normally start because of what's happening in the skin, they will shut this down. Now, what this means is the more UV radiation that bombards and is able to get to your skin, the more damage you're going to do to these cells. Okay? These are your antigen-presenting cells. These are cells that actually are responsible for grabbing bad things, internally dealing with them, and presenting a form of it to the surface so that your other immune cells in the body can recognize it as something bad, especially like a cancerous cell, that kind of stuff. Okay? Now, if you damage these, they are very susceptible to UV damage. Not only do you destroy cells that help you target bad things, but you also leave behind more of these cells. And now it's out of whack. If you have more of these cells, a disproportionate amount anyways, in terms of what's supposed to be there, of these compared to these, what do these guys do? They shut things down. So not only do you lose the effectiveness of these cells, you actually decrease the total immune activity of your skin anyways. So the more UV damage that you get, the more that you're bombarding. That's why there's an increased risk of skin cancer, the increased risk of melanoma with UV ray bombardment, because you actually can destroy these cells, leaving behind unchecked situations whereby the immune response shuts down. So if cells are damaged, if cancerous cells do form, our body wouldn't do. A person who's bombarded a lot with UV radiation doesn't deal with it very well in terms of a normal person. Okay, they won't. This is out of whack. They can't deal with those cancerous type situations. So you get these presence of these melanomas. Now we are, as a race, a little bit different, right, than people of darker heritage. So they would have more melanocytes to help combat these problems because of the region in which they live. They would have more UV filtration to decrease this likelihood of Langerhans cells. Especially when artificially induced, we're not designed to be that way. So when we do that, we don't kick this up. We kick this up a little bit, but we can't kick it up as much as most of the people, obviously, that are indigenous to that area. We don't look anything like them whenever we try to do this. But we do. Our body is trying to protect itself. So we hurt our body in the sense that it's trying to protect itself. It's producing more of this so as to try not to kill so many of these and allow so many of those to be present. So anyway, just something to think about. Also, the skin synthesizes vitamin D. It's derived from a cholesterol precursor. You've got this little molecule floating around that comes from cholesterol. I'll explain that later. But it requires some radiation from the sun in order to convert it into a usable form of vitamin D. It gets absorbed through the skin, and it can convert that molecule into actual functioning vitamin D. Now, why do we need vitamin D? This makes sense because it's why calcium milk is fortified with vitamin D. Okay, you see that on the labels all the time. Vitamin D promotes digestive absorption of calcium. The vitamin D works in our body so as that we don't absorb hardly any of the calcium out of the food and the drink that we put in our bodies. Without vitamin D, we would get even far less. So we need the absorption of calcium, and vitamin D helps us do that. That's why it's a good place to put it in to a source of calcium. Put it into milk because there's a lot of calcium in milk anyways. Put vitamin D in there, you're going to absorb even more of that calcium than you normally would if vitamin D wasn't there. Okay, just some general things that can help with immunity. We've got saliva, pH of the stomach. It's very acidic. Obviously, can kill a lot of things. Normal microflora in your gut. Now, realize that the biggest role that the bacteria in your gut are going to play against the immune response is for competition. They're going to take up space and utilize resources, and they're going to be those that do not really harm us, so that those things that could harm us when they come in there don't really have a place to stake claim to. It's a lot harder for them to get situated and to get growing. So competition is very important there. In the genitourinary system, we've got mucosal secretions, the pH, especially in the female, like with the vagina's pH is very acidic. In the respiratory system, nasal hairs physically prevent things from coming in. Adenoids, which think of like your tonsils, but your adenoids there and back there. Mucus escalator, the whole moving stuff up, right, in your trachea. You're going to find IgA antibodies. If you think back to when I talked about the antibodies and listed them all down there, I said these are going to find in the respiratory tracts and the mucous membranes. That's where you're going to find these. So in these areas where you have these mucus secretions, you've got the escalator in the trachea, that's where you're going to find a lot of these IgA antibodies. Okay? Alveolar macrophages. In our lungs, we have generic macrophages that are in our alveoli because that's a sort of a first point where our environment can come in contact with our body. Cigarette smoking, okay, suppresses these normal respiratory defenses. Not that, I'm not trying to pick on anybody. I just got to make sure I throw this in with every chapter. Smoke from one cigarette can paralyze cilia for several hours, eventually leading to destruction. Okay, it's not just nicotine you put in your body. You get the whole list of chemicals that can be found in cigarettes. It's quite disturbing. Also, incapacitates alveolar macrophages. So by putting these chemicals in your body, two things are happening. As it's passing through, the first physical defense that you come in contact with are cilia, and it actually can sort of fry them, at least. It can incapacitate them to where they eventually destroy very easily as those chemicals are passing through them and the cells that are producing them. Also, when it gets into the lungs and that nice fresh air from the cigarette fills up those alveolar sacs, you have some macrophages in there that are residents of that area that are damaged by that. So that increases your risk of infection. That's why you're going to get more mucus buildup later on in the year. That's why you're going to get smoker's cough. That's why you're going to get all these things. You get a decreased immune response in the respiratory system. You actually destroy the immune cells associated with it. Also irritate the linings, causing excess mucus production. Anytime your lining is irritated, your body's natural response is to replace that which is lost and to try to overcome by immune response. One of the things is to produce more mucus, and it will do that. That's going to contribute to smoker's cough. So, if you want to know any more about cancer in terms of information, animations, I threw that website in there. It's pretty good. There's a lot of info on there.